We are interested in how the structure of natural language used by an embodied agent relates to the structure of the underlying decision processes being solved by the agent. We posit that understanding this relationship will help us in building embodied agents to solve complex problems. The widely used model of embodied agent is the Markov Decision Process, which represents the interaction loop between an agent and its environment. It is a generic, flexible, unstructured model of an embodied agent in which we have a state space that describes the world, actions that the agent can execute, transition dynamics, and a reward function that the agent must maximize. We'd like to communicate with this agent using natural language, which in contrast has a very rich structure. Natural languages have important functional elements that allow for the composition of rich sentences, both in structure and in meaning. These elements are widely known as parts of speech, and they include functions such as nouns, verbs, determiners, adjectives, adverbs, and others. In order to exploit information in natural language, we need to map information from the parts of speech to knowledge about the MDP elements. A simple approach would be to have a state correspond to nouns, actions to verbs, specify transitions to conditionals, and specify rewards and values with cardinal and ordinal quantities. However, with very little structure provided by a generic MDP, some parts of speech are in general not realizable. For instance, consider the MDP on the right that has 5 states where the green state is the goal. We can name these states with the noun goal, but it would not be possible to ground the notion of an object as we know it in such a simple MDP. Consider a terrace for Montezuma's Revenge with the state corresponding to the pixel values in this image. In factory MDPs, we are able to identify elements that determine the state in a syntagmal representation. Such are the cases of the skull, the key, and the agent in this environment. These can be named by proper nouns. Moreover, adjectives are now possible as we can qualify proper nouns by tying the adjective to a specific state of these elements. Transitive verbs, those whose effect is on a noun, can be grounded here. Consider, for example, with the instruction grab the key in this environment. By introducing the notion of objects and generalizing using object classes in the state representation, we get object-oriented MDPs, where there is a collection of object classes for which we have specific attributes. And this way, environments such as Montezuma's Revenge that are object-oriented can generalize the properties of elements such as stairs, and have many instances of it. Now, with this structure, we can ground common nouns to talk about object classes. We can use determiners and adjectives to discriminate among object instances, and transitive verbs are now generalized to apply to object classes. Consider now the structure in the action space. This can be partially achieved in hierarchical frameworks where options can be verbs, and in object-oriented MDPs with transitive verbs. However, there are also parameterized action MDPs, in which discrete actions have a continuous parameter that determines some characteristic of the action. We can ground adverbs to some subset of these parameter values and allowing the possibility of qualifying verbs. Finally, we wanted to highlight that much of the information in natural language goes into factual information, which is not informative for observable processes. Consider a robot navigating the map on the right and represented as an object-oriented MDP. If we were to say the stove is hot, this fact would not be informative as the agent knows its state and hence the attributes of the stove. However, in the presence of partial observability, such statements become very important as they help reduce uncertainty. Here, verbs such as could and should allow to specify uncertain information. The main takeaway here is that the richness of language stems from the richness of the underlying decision process. For instance, unless we have parameterized actions, there's no need for adverbs, and in observable world, facts are not informative. Highly structured formalisms are necessary to exploit natural language information.